Alright, next we move to the trap seals and reservoir rocks. So how does the petroleum accumulate? Okay, it's actually by trapping of all the petroleum from migrating upwards to the surface. Okay, so traps is any combinations of permeable rocks that holds commercial quantities of petroleum. So if nothing stops the oil from rising, it will reach the surface. Okay, so traps can be rocks that do not allow any fluids to pass through them, or faults in the rock that can trap the petroleum. So we have three types of traps: structural, stratigraphy, and combination. Okay, so for the structural traps is actually if the trapping is exclusively due to the structural traps and are formed usually by the tectonic forces. So you can see here the anticlinal, right? It is where rocks that are folded and bent outwards. So the hydrocarbons normally will migrate up to the flank of the anticlines and will be trapped in the crest. Okay. Meanwhile, for the faults, it usually occur where there is movement along a joint or fracture. So it is the offsets of the beds that could result in an impermeable layer being on top of a permeable layer. So normal fault is more efficient in trapping the hydrocarbon because these faults has higher permeability pathway compared to the reverse faults that makes the hydrocarbon readily to move on the amounts in the higher amounts that will then replace the displacement area in the reservoir rock. So structured traps are easier to find than others, but the oil reserve they contained show clearly that generally they are also a bigger traps. Okay, so this is the terminology of an anticlinal traps. Okay, I think you know about this, right? It's where the normally we will define the gas oil contact and the oil water contacts. So closure here is the vertical distance from the highest crest or the highest points to the spill plane or points. It's actually a level at which the oil spill below the trap into the adjacent permeable beds. Okay, GOC here is the distance from the top of the petroleum accumulation, right, to the lowest point of the oil water contact. Okay, this is the gross pay zones, while the net pay zone is the commercial productive parts of this interval of the gross pay zones. Right, so next, the stratigraphy traps is actually if the trapping is exclusively due to the stratigraphic disposition. So how does it occur? Simple. When the rock layers changing from a good reservoir to non-reservoir due to the change in the rock type, for example, pinch out, reservoir quality, okay, due to diagenesis or removal due to erosional unconformity. So as example, we do have here unconformity that is caused by a period of erosion and deposition. They represent a gap of they actually represent a gap in the geologic record. In other words, a period of erosions or non-depositions. So unconformity actually they can result in the truncated of the permeable reservoir rocks and overlain by an impermeable unit of rock. Okay. So the risking of finding the hydrocarbons, okay, through the stratigraphic track is actually greater than the structured traps, okay, because oil column that the oil column that preserve in the unconformity, for example here, is actually more parallel to the bedding plane. Okay, so it's easily can leak if there was only one small seat belt within a low with a low I mean slow small seat belt, okay, in the impermeable rock with a low displacement pressure. So it will later cause and force the hydrocarbon to move into or pass through the beds, right? As the buoyant force of the oil is actually directed update and parallel to the bedding. Okay. So another examples of stratigraphic trap is the salt diapers. It's actually caused by the upward movement of sediments that are less dense than the surrounding or than those overlying them. Okay. So salt okay, then we do have the combination traps. Okay, this trapping is either due to the structure or non-stratigraphic or due to stratigraphic depositions alone. So how does it occur? Is normally occur due to the change of rock types, which this commonly happen in stream environment where sand is deposited along the stream channel, which is surrounded by a flat plain that is characterized by finer grained sediment. Okay, sometimes it's formed due to a lateral change in environments of deposition, in which a lens of permeable sand is surrounded by less permeable siltstone and shale, and forming a pinch-out traps. Okay, next, how does the petroleum accumulates? Okay, this is the last stage of the petroleum system, the last process of that accumulates in the petroleum systems. Okay, so during the accumulation, there will be preservations, right? So preservation is the process where hydrocarbon that will be accumulated and where the alterations of petroleum take place in the reservoir rock. Okay, normally this is the process where petroleum geologists normally will ask whether is the oil has been removed or preserved, or is the oil has been altered. Okay, so for the petroleum to accumulate, right, we need the reservoir rocks. So reservoir rock is the rock that having appreciable porosity for hydrocarbon to be trapped and sufficient permeability for oil to flow during migrations and productions. So the characteristic of that rock must be coarse grained clastic sedimentary rock, any porous limestone, and or any fractured igneous and metamorphic rock. Okay, and the timing between the accumulations of organic matter, petroleum maturations, petroleum migrations, and trap formation has to be vital. Okay, so you can see here the reservoir rock of sandstone with the good porosity. Okay, lots of space for petroleum to be preserved within the pores. Well, meanwhile, this one, the pores has been cemented, right? So there's no, I mean, it's obviously it's really poor in porosity and permeability for petroleum to be accumulated in the pores. Next, how does petroleum preserve? Okay, it's by the presence of seal rock. Okay, that is the rock that prevent further vertical and lateral migrations of hydrocarbons from the trap. So the characteristic of that seal rock normally is a fine-grained impermeable sedimentary rock. So a seal that is a fine-grained rocks that prevents the oil migrating to the surface or vertical migration. Okay, so the seal is actually an important component in a prospect. So common seal here in order of importance starts from the gas hydrate, salt, evaporites, and chalks that provides an effective seals, but muddy, chalk-rich, clay-rich rock, mud rock, shales and siltstones, which very fine-grained sedimentary rock is they are represent most of the seals around the sedimentary basins. Okay, and then we do also have the low permeability carbonates, faults, and asphalt as the seal of the lowest importance. Although they are also found, but they are uncommon throughout the sedimentary basin. So gas hydrates here is actually very effective because it can hold 6 times as much gas as free gas held in the same space. Like it is like a ice structure of water that has crystalline looks like a solid wet snow. Okay. Meanwhile, evaporites here also can be an excellent seal because the capability of salts that can undergo plastic flow at an elevated temperature, because salts has small size of crystal that can prevent the vertical migrations of hydrocarbon. Okay. For the muddy rocks, it is actually clear minerals that actually has to be more than 40% so that the rock can become ductile. Okay, and with the high corrosion content, okay, it can make in that rock, it can make that rock, for example shale, become more ductile, because more ductile can cause less fracture due to less in brittlleness. If there are a lot of fracture, the rock could not prevent the migrations of oil to the surface because fracture provide mobility pathway for migration to be occur due to the break of the seal. Okay. Next, we have the asphalts that is actually occur at the shallow depths due to biodegradation process and weathering. So it can provide barrier for oil and gas to move upward to the surface. Okay. To quantify the seals, okay, you can conduct an analysis of seal involves assessments of their thickness and extent, such as their effectiveness and effectiveness that can be quantified. Okay, and then you also need to know the knowledge of sequence hydrography that is actually crucial for better understanding of the seal. Alright, so the summary of the petroleum system. Okay, where does petroleum come from? Okay, so source rock that is rich in organic matter, okay, has to be the first elements in the petroleum system. We have to remember that the source rock has nothing to do with the reservoir rock that contains the oil in the oil field. So the source rock is the rock that can generate the oil, okay, and later migrate the oil and later expel the oil into the carrier beds, right? And that petroleum later will be migrated into the reservoir rock. So the source rock can be 10 kilometers away from the oil field. Okay, then the organic matter in the source rock itself will be transformed to the corrosion during diagenesis, and then later will be compacted into the petroleum by the heat and pressure during catalysis process. Okay, so when the corrosions the oil that is less, when the corrosion in the source rock become matured during catalysis process, the oil and gas will undergo primary migration, which is the oil and gas will migrate from the source rock to the carrier beds, and later the migration path will allow the generated petroleum to move to the trap by the secondary migrations. So oil that is less dense than water will going up through the fluid system of the surrounding rocks. So the carrier beds here is the rock layer that allows fluids to pass through them. If petroleum stay buried, it can become post-matured. Okay, and then traps such as structure traps or faults or anticline will prevent the oil from going up or leak, as well as the sea rock that will keep the petroleum below the ground occur during accumulation process. So at the same time, an adequate reservoir beds from which the petroleum can be extracted will preserve this accumulation with the help of sea rock and cap rock. Okay, so to make this perfect process in relation to the elements for an accumulation, there must be a proper timing of event from the generations until preservation.